In this video, we're going to talk about polynomials. So let's go over a few basic things before we talk about polynomials. Let's say you have x to the 0 power. So x to the 0 power is 1. And if you have 5x squared, the x right here is called the base. And 5 is called the coefficient. And of course, 2 is called the power or exponent. And let's take a look at common polynomial functions. So we call that polynomial is in standard form if it's in order of descending order of power or exponent. So notice that powers or exponents are descending order. And we call that a polynomial is in standard form. So first type is constant. For example, f of x equals negative 14. That's a constant polynomial. And when you graph this, you get a horizontal line. Next, we have a linear. When you have a of 1, x plus a of 0. For example, f of x equals 5x minus 7. A linear polynomial. Of course, when you graph that, you get a straight line. Next, we have a quadratic. An example of quadratic is 2x squared plus x minus 9. And the degree, when we say degree of the polynomial, that represents the highest power of that polynomial. So the degree of quadratic will be 2, and degree of a linear will be 1. And we have a cubic. Example of cubic is x cubed minus x squared plus 3x. And of course, the degree is 3. And also, we need to talk about leading coefficient. Leading coefficient is the coefficient of the term that has the degree. So for example, leading coefficient of this will be 1 because the degree is 3. What about this one? Leading coefficient will be 2 because the degree of the polynomial will be 2. And leading coefficient of this will be 5. Now, we got quartic polynomial, means that degree is going to be 4. And the leading coefficient of this polynomial will be 1. So for example, f of x equals negative 2x cubed plus 5x plus 8. Is this in standard form? It is, because the exponent is in descending order. What will be the leading coefficient? Leading coefficient is negative 2, because that's the coefficient of the highest power. Okay, leading coefficient is negative 2. What about the degree? Degree is 3. And what kind of a polynomial is this? This is cubic because the degree is 3. Now, g of x is not in standard form because x to the 4 is greater than 3, so you have to rewrite this. You have to rewrite this as g of x equals radical 2 x to the 4 minus 0.8 x to the third minus 12. Now this is in standard form. Now what is the leading coefficient? Leading coefficient is radical 2. And what is the degree? Degree is 4. And what kind of polynomial is this? This is quartic because degree is 4. Now h of x is not a polynomial because the exponent is negative. In order to be a polynomial, exponent cannot be negative. And it has to be 0 and positive integers for the exponents. And what about k of x? X squared plus 3 to the x. This is not polynomial for 2 reasons. First of all, base over here. The base is not x. And the exponent is not a positive integer. So k of x is not a polynomial. In order to be a polynomial, the base has to be variable, and the exponent has to be 0 and positive integers. Now we have f of x equals 2x to the fourth minus 8x squared plus 5x minus 7. What if they want you to evaluate when x equals 3? All you need to do is find f of 3. So this means when x equals 3, the y value is f of 3. That's what f of 3 means. In order to evaluate, then we have to substitute 3 for x. So we end up getting, this is going to be 2 times 81, because 3 times 3 times 3 times 3, minus 8 times 9, plus 15, minus 7. I'm just using the order operation. We end up getting 162 minus 72 plus 15 minus 7, and you end up getting 98. So when x equals 3, the y value will be 98. That's what it means. What about if you want to evaluate when x equals 0? In other words, we got to find f of 0. That's pretty simple because 0 times anything is 0. So that goes to 0, this goes to 0, that goes to 0. You end up getting negative 7. That means when x equals 0, the y value will be negative 7 on this polynomial. What about this one? When x equals 3, the y value will be 98. That means this polynomial will have a point at 3, 98 and 0, negative 7. Now let's talk about end behavior of polynomial functions. By knowing the degree and the leading coefficient, we could see the behavior of the polynomial, and this is what I mean. If the degree is odd and leading coefficient is positive, that means as x goes to positive infinity, what do you mean by positive infinity? That means the number is getting greater in positive direction, like 1,000, 10,000, million, billion, and so forth. As x gets bigger in positive direction, what happens to y, which is f of x? The y value, f of x, is going to positive infinity. So the graph will look like this. But when x goes to negative infinity, what happens to f of x? The y value goes to negative infinity. Negative infinity means that number is getting bigger towards the negative direction. So negative 100, negative 1,000, negative 1 million, and so forth. What about when degree is odd and leading coefficient is negative? Then, as x goes to negative infinity, the y value will go up. And as x goes to positive infinity, the y value will go down. Now, we don't know what's going to happen in the middle. Only thing that we know is what's going to happen at the end. That's why it's the end behavior of a polynomial. Now, what if the degree is even and the leading coefficient is positive? Then this will happen. It goes up and it goes up. What about degree is even and leading coefficient is negative? Well, they both go down at the end. So you have 4 cases of end behavior depending on the degree and leading coefficient. Again, we don't know how the graph will behave in the middle. So be careful. This is only the end behavior. So let's look at this polynomial. And how would the end behavior look like? Well, the degree is 4, which is even. What about the leading coefficient? Leading coefficient is negative 0.5, which is negative. So it's even, degree is even, and leading coefficient is negative. So how the end behavior look like? We don't know. Again, we don't know what's going to happen in the middle, but we know that it's going to look like this. Okay? So let's use Desmos and see the actual graph of this polynomial. So using the Desmos, as you could see, look at the end behavior. They both go down because the degree was even and leading coefficient was negative. Again, we don't know how the graph's going to behave in the middle, but we definitely know how the graph will behave at the end by you looking at the degree and the leading coefficients.